All right, so here we go. This is a car that we have. So we'll just try a little car here on this side, and the car got stuck in the mud. So we've had this problem on the farm before when we have a truck or we have a tractor stuck. And so what we do is we just tie a rope to the front of the car and then we pull it. So I'd be standing here, Dad would be over here in the truck, and he would start driving, and I would pull that line this way, and it would actually then pull the car out of the mud, which was kind of cool. The rope that we would use would be about 12 meters long, and so that's what you see in the problem. So each side of the rope on either side of me is only 6 meters. And typically you'd only need to move it about 1 meter in order to start that car really moving out of the mud, which was kind of cool. I'm going to pull with a force here of about 610 newtons. So that force is in this direction. And I want to know, what is the force of tension in the line? So to do this problem, what we're going to do first is let's just draw one of the triangles. So let's start with the triangle here. And we know that I have a 1 meter distance that I'm pulling. We know that the rope itself is 6 meters long. So let's figure out what is the angle that it makes between the two of us here. So I'm going to go ahead and use some trigonometry. And the first thing I need to do is say that the tangent of the angle is equal to my opposite side, which is 1, over my adjacent, which is 6. So the angle is equal to the inverse tangent of 1 over 6. And if you do that math, you end up with 9.46 degrees, and that's the angle that you see right here. So let's go back to our diagram. Now this one's a little bit different because we now have a force of tension that is going this way, so that's Ft. We have another force of tension that is going this way, and then you have in the middle, you've got a force, and the problem with this force is I know that the whole thing is 610, so I have 610 newtons going in this direction, going up. But because we have two lines, we're going to take that 610 and divide it by 2, because if you think about the force just on one of the triangles, so we're just going to look at the triangle here on the right, that triangle, the force moving towards me, or what I'm pulling with, is only really about 305 newtons. We want to find what is the force of tension on this side. And that's really kind of all we're really looking for. We know that the angle here is about 9.46 degrees. And so if I want the force of tension and I know the opposite side, this is the hypotenuse, we can use sine. And so I'm going to go ahead and set this one up. We're going to say the force of tension then is equal to the force that I pushed with, which is 305, or pulled with, divided by the sine of 9.46 degrees. And if you divide those two, you get 1,860 newtons. And so that's a tremendous amount of force just by taking a really tight line and trying to pull towards this side. So that is the answer to equilibrium exercise B3.